This video introduces drawing basics in C# Windows programming. Here is the overview of the video. First, I talk about how to draw to screen using form.createGraphics. Then I'll talk about how to trigger and handle the event form.paint, which exists in every form. Then I'll talk about colors, how to create a new color, or how to use one of the currently existing color using form known colors. Then I'll talk about brushes, different types of brushes, the solid brush, texture brush, hatch brush, linear gradient brush, path gradient brush, and then finally I'll talk about pens, the line cap of a pen, and its dash style. Although Microsoft Windows Forms are pretty rich and they have lots of built-in controls, sometimes it's not good enough to show the state of your application using those controls only. In these situations, you want to draw your own shapes, your own images, your own strings. And to do these, you need to deal with the same primitives, which are colors, brushes, pens, and fonts. In order to see how it's possible to draw shapes and other graphical primitives in a Windows form, let's see a very simple example. This example shows you how to create or how to draw an ellipse with fill color dark blue on the middle of a form that fills the whole form. In order to do that, let's say there exists a button called Draw Ellipse button, and that button has a click event handler called Draw Ellipse button underline click, and basically this method, this event handler, is going to draw a big ellipse at the middle of your form. How does it do the filling and the drawing? Basically, it uses a local variable called graphics, G, right? The variable is called G, the type is graphics, and it initializes the variable G by assigning it, by setting it equal to this.createGraphics. The createGraphics is a method, it's a public method that you can use on any form, and it allows you to basically draw multiple shapes on it. In this case, what I want to do is I'm going to draw a single ellipse on the middle of the form. So I first create a graphics object by initializing it this way, set it equal to this that created graphics. Using is a reserve word in C# that allows you to create a nice block. This block defines a local variable G, and this the scope, the view scope of G is limited to this block, right? So basically, you're limiting the viewing scope of this variable. We don't need to use G anywhere else, so we just use this using block, and then inside that we say let's draw an ellipse and fill it with a dark blue color. So we say g.fill ellipse, brush.dark color, and then the rectangle that we want to use to specify the dimensions and location of the ellipse would be this.client rectangle. Client rectangle is basically the whole form, the rectangle that covers the whole form. So it basically fills the whole form with a big ellipse at the middle, right? And this only happens if the Boolean draw ellipse is set to true. Originally it's false, so you don't see anything on this screen. But after every click on this button, we're gonna flip the boolean. So false becomes true, true becomes false. So if it's true, we're gonna draw the dark blue ellipse. Otherwise, if it's false, we're gonna draw uh, another ellipse with the same dimension, same location, but this time the color would be system brush as the control, which is basically the same color as the default background color of every form that you create. Basically, this will erase the previously drawn ellipse, and that's a common technique. Whenever you want to erase some shape that you have already drawn, you basically redraw the same shape using the background color. This way, it's gonna get faded in the background, and you're not gonna see it anymore. Here is how the form that we created in the previous slide looks like when you run it. Basically, by clicking on this button, draw ellipse, you will see a big blue ellipse on the form. And the problem with this ellipse is that when you change the size of the containing form, like when you, let's say, making the form bigger, uh, you don't see this ellipse to be redrawn. It stays the same way, and uh, it doesn't kind of look good because it doesn't dynamically change its dimensions as you change the dimension of the containing form. If you make the containing form bigger, the ellipse remains the same. If you make it smaller, like in this snapshot, it still doesn't change its size in a dynamic fashion. So it stays the same because you're not drawing the form, drawing the ellipse in a dynamic fashion. You only draw it once and it stays the same size. In order to deal with form resizing, Windows asks a form to basically redraw the content using the Paint event handler. What is Paint? Paint is an event for every single form that you create, and it's an event handler basically gets two input parameters. The first one is the sender, the object sender that every event handler receives. The second one would be basically the paint event arcs. It's not going to be event arc, it's paint event arcs. That's basically a subclass of or a subtype of event arcs. What does a paint event arc contain? It contains the graphics object, so you don't need to create your own graphics object. It currently has one. So all you need to do is to handle the paint event of a form, and basically in the event handler, just simply use e.graphics to create an object or to um, access the object of the graphics class. And then using this e.graphics object, you can call methods like fill ellipse, and basically this will draw you an ellipse with whatever color you want, in this case dark blue, and in whatever rectangle you want. In this case, I want to draw it on the rectangle of the form that covers the whole form. After you handle the paint event for the form, you should also trigger that event by doing one of the following methods. You can either call invalidate. For example, let's say if the user clicks on the draw ellipse button, you can say this.invalidate true, and this basically gives the Windows form heads up that this drawing is not valid anymore. So whenever you get a chance, let's refresh it, right? Or you can basically use update. That's gonna force the paint event to happen. It's a little bit more urgent than the invalidate one. The invalidate one will trigger the paint event soon, but the update will force the event, the paint event to happen right now. And then you can use an alternative option of calling the refresh method, which basically does both the invalidate and update at the same time. So let's say we have already implemented the paint event handler for this form, and in the click event handler of this button, we have already triggered the event using invalidate, but this doesn't help or doesn't fix the problem that we had with resizing of the form completely. In order to fix it completely, you need to also use this set a style method and say this dot set a style to control styles that resize redraw, comma true. This basically causes the windows to redraw the entire client area whenever the form is resized. So just remember this tiny detail. If you want, every resize causes a redraw and causes a paint event trigger. You gotta use this this line. Basically, you can place it, let's say, in the constructor of the form, for example. Microsoft Windows form applications use RGBA format for representing colors. So basically, they use 4 different separate intensities for the red color, the green color, the blue color, and for the transparency. Let me give you an example. The RGBA format provides a number between 0 and 255 for the red color intensity. It provides another integer from 0 to 255 for the green color intensity, and another number or another intensity from 0 to 255 for the blue color intensity. A combination of these 3 is going to give you a different color. For example, if you want to make a purple color, you can have some red and some blue. The combination of these 2 will give you purple, right? Or you can create, you can mix these 3 and create different colors if you want. You don't need to basically use the maximum intensity. You can use different intensities. Each one has 256 different intensities. 0 would be the minimum intensity, which means you don't use that color. So if the green intensity is 0, that means we don't use any green. For purple, you don't need any green, so you use 0 for the green intensity. And then 255 is the maximum intensity. Let's say for purple, I use 255 for red, 255 for blue. You can use, let's say, 127 if you want 50% intensity. You can use 64 if you want only 25% intensity, right? So you can use different values of intensity. You can use any intensity for any of these 3 colors, and that's going to give you 16 million different colors, which is a huge number, right? It's basically to the power of 24, because the number of thread intensities would be 2 to the 8, 2 to the 8 for green, 2 to the 8 for blue. So the total combination would be 2 to the 8 plus 8 plus 8, which is 24. But these are assuming there is no transparency. you can have transparent colors. Transparent means what? It means that it blends with the background, right? So when you have a, let's say, uh, object that is filled with a transparent color and it is placed on a background of a different color, the color of the foreground and background will be uh, blended in some way. The more they blend, the more transparent it is. Or I should say the opposite. The more transparent it is, the more it blends with the background. Now, how do we know what the transparency is? We use a fourth number. So other than red, green, and blue, we use another number. We call it alpha, which represents the opacity. The opacity is the opposite of um, transparency, and it's a number between 0 to 255. If you want the most opaque one with no transparency, then you use 255, right? Normally they call this alpha. And if you want complete transparency, then you use 0. That's nonsense, because 0 transparency is just like 0 opacity means full transparency means you don't even see the color of the object because it is completely showing the background color, and it doesn't show the actual color of the current object. But if you want like 50% transparency, then you set the alpha to 127 or 128, right? Each of these four pieces are represented by one single byte, because their values range from goes from 0 to 255. Each one can be represented by an 8-bit unsigned binary number. So basically you need 1 byte for red, 1 byte for green, 1 byte for blue, and 1 byte for alpha. It's going to give you a total of 4 bytes for the color of every pixel that you draw on the screen, right? So this is how the colors are represented in Windows Form applications. The actual C# code looks like this. We have a structure color in the namespace system drawing, and as you see, it has all the 4 elements. A stands for alpha, R stands for red, G stands for green, B stands for blue, and it has some other methods as well, right? As you see, you can create a color using ARGB. If you combine the 4 numbers that I showed you into one number, you can pass it as an only input parameter of this method. You can separate the alpha from the color, so you can separate the alpha from the other 3. You can pass red, green, and blue separately to the form ARGB. You can pass all 4 values, alpha, red, green, and blue, in 4 different input parameters, as you see here. Or you can use one of the known colors. You don't need to create your own color if you already have one available. And yeah, basically this structure serves as the main tool in Windows Form application to specify a single color. Here's an example of using uh, the methods defined in the color structure. Uh, let's say you want to create an opaque red color. Then you say color red equals color that from ARGB 255 as the red intensity, 0 as the green, and 0 as the blue intensity. That's going to give you the most intense red. For green, 0 to 55, 0. For blue, 0, 0 to 55. And then if you have all the 3 components set to maximum, it's going to give you white, because it's a combination of all the 3 colors. It's going to give you white. If you instead of 255, 255, 255, if you reduce the intensity of all 3 to the same amount, let's say 127 or 64, it's going to give you a shade of gray. So if you want to get a shade of gray, there are 254 of them. All you need to do is to set red, green, and blue intensities equal to each other and not equal to the maximum or minimum. If you set them all to maximum, you get white. If you set them to 0, you get black, because black has no red in it, no green in it, and no blue in it. If you want to have some transparency, let's say you can say, let's have 255 times 1 over 4. That's going to give you 25% opacity, or 1 minus 25%, which is 75% transparent blue color. Why is it blue? Because alpha is 255 over 4, but red, green are 0, and blue is maximum. So that's going to give you a 25% opaque blue. If you want to use the other overloaded version of the method from ARGB that gets only one number by mixing all the red, green, blue intensity and alpha, then you have a hard time to do that, because you gotta mix all of them using this weird looking formula. This formula basically combines the four numbers in a way that uh, they make a 32-bit signed integer in 2's complement notation. If you don't know what 2's complement is, forget it. But if you know, basically, all you need to do is to place the 8-bit of alpha first, then 8-bit of red, then 8-bit of green, then 8-bit of the blue. Then it's gonna you're gonna get a 32-bit integer. Treat it like the 2's complement number, transfer it, or you convert it to either an integer or hexadecimal or octal, whichever you like, and then pass it to the color.form ARGB. Here, as an example, if the alpha is 191, red, green are 0, and B is 255, you're gonna get this number, right? This is basically a 75% opaque blue color. This is more opaque than the 25% one. So A is 191, red and green are 0, blue is 255. If you plug in these numbers into this formula, you get this negative integer, and then you just pass that negative integer to color.form ARGB as its only parameter. If you want to use one of the predefined colors, then you don't need to use the method I showed you in the previous slide. Instead, you can basically use a code like this. For example, color.blue or blue-violet gives you a constant color, or color dot from known colors, and then, for example, known color dot active border. That's a color of the active border of a Windows form. Or, for example, color dot from name, and then you can pass a string that's the name of the color, in this case, active border. And this way you can basically create one of those predefined colors. Here is the list of all the known colors. You can take a look at them. Next, I'm going to talk about brushes. Brushes are used to uh, fill a drawn shape with a certain color or with a certain texture, or basically using a linear gradient pattern or a path gradient pattern. There are different types of brushes, but they're all are subclasses of system.drawing the brush. That would be the base class of other brush classes like solid brush, texture brush, hatch brush, linear gradient brush, and path gradient brush. The simplest type of brush would be solid brush. You can either use one of the pre-existing brushes like this one, like system drawing brushes.white. That's going to give you a white solid brush. Or you may create a new solid brush by passing a certain color to it. So if you want to create the same white brush, you can say new solid brush, and then you can pass the color white, which is color.white. Another brush type is called texture brush. which basically is constructed with an image. All you need to do is have the image file stored in a BMP file, a bitmap file like this. Let's say start with the BMP, and then write down the location or the path and the name and the extension of the file that you have, and then use that string as the input parameter of the constructor of a new bitmap, and then pass the bitmap object to the constructor of the texture brush. This way you can create a texture brush with a given file, and basically that file is used to fill the shape that you want to fill its interior with a certain brush. So uh, when you're filling the interior of a closed shape with a texture brush, you can select different wrap modes for the texture brush. You can either uh, set it to the default mode that's not going to do anything special, or you can use tile flip X, tile flip Y, tile flip XY, or you can simply use clamp. Clamp, draw the image once in order to fill the area that you want to fill, but the other four are going to repeat the same image multiple times. Uh, Tile simply repeats it, so it basically tiles the whole area with those images. Tile flip X uh, basically repeats the images, but each time flips the image with respect to the x-axis. Um, Flip Y after it fills the whole image with tiles after flipping the tiles in Y direction, and tile flip XY flips it in both X and Y direction. I'm going to show you an example in the next slide. Here's an example of texture brush. I have filled the ellipse that I showed you in previous slides using the texture brush, and the texture brush uses this figure. As you see, this is the original image. If I basically use the wrap mode tile, it's gonna show you this figure. Basically repeats that image to tile the whole ellipse. If I use flip X, then it's going to show it this way. As you see, it flips it with respect to, I'm sorry, it uses this one. This is the flip X. It flips it with respect to the x-axis. This is the x-axis. And if you say flip Y, then it's going to do flip it with respect to the y-axis, and if you do X and Y, then it's going to show it this. Then it's going to fill the whole ellipse using these tiles, which are flipped in both X and Y axis. The next type of brush is the hash brush. Basically, you can create a hash brush by passing three parameters. The first one is the hash style. You can see all the available hash styles. Then you can pass two colors. One of them is the fore color, one of them is the back color, and then using these two colors and the style that you give, you can create a unique brush. Here's an example of a hash brush. I filled the same ellipse that I showed you in previous slides using the hash style large checkerboard, the foreground dark blue and the background yellow, kind of like the FIU colors. And as you see here, uh, these three parameters are going to be passed to the constructor of the hatch brush, and it's going to create a new brush for you, and that brush is used to draw to fill the ellipse. Now let's say you want to create a brush that um, colors the interior area of a shape like an ellipse with two separate colors, and the colors are going to be, in this case, green and blue. And then what you want is you want a gradual linear change from one color to the other color when you're moving from one side to the other side. This is how you can create such a brush. You can say, let's create a new linear gradient brush. Pass the rectangle that this brush is going to be applied to, pass the first color in the left side, pass the right color in the second color in the right side, and then specify the linear gradient mode, either horizontal or vertical. And then, this will happen. If I use this brush to fill my ellipse, I will see this shape. Here is another example of linear gradient brush. As you see, I have set my first parameter of this constructor for the linear gradient brush equal to a new rectangle of location 0, 0, and the size would be 1/10 of a height of this form and as the width, and 1/10 of a height of this form as the height. And this has created the pattern that you see here. The first color is green, the second color is blue, and I have used the same horizontal gradient mode. And as you see, it has to repeat a pattern in order to fill the whole ellipse for me. By changing only the linear gradient mode from horizontal to vertical, I will see this shape, this type of brush. As you see, the last parameter is set to linear gradient vertical. That's why I see the vertical filling or the vertical repetition of this linear gradient brush. If you want to set the first color to the extreme ends and the second color to the middle of the shape, then what you need to do is to call this method setBlend triangular shape, and basically use 0.5 that basically specifies the focus of the second color to the middle, and the sides would be colored with the first color. But you still need to create the same linear gradient brush with the same colors in the same horizontal mode. If you want the color distribution to follow a normal distribution or a bell-shaped distribution, what you can do is you can say the linear gradient brush that sets sigma bell shape to 0.5, and this will basically distribute the color, the two colors green and blue, using a bell shape function. At the middle, you have the highest intensity of the blue color and no intensity of the green color. As you come or as you get further from the middle and you get to the sides, you will see less blue and more green. For the linear gradient brush, you can blend colors in a much more complicated fashion. Let's see an example. Let's say you have created a new linear gradient brush with the linear gradient mode equal to forward diagonal. It doesn't need to be horizontal or vertical. It can be diagonal as well. It can be forward diagonal or backward diagonal. And then I have created a color blend object called blend, and I have defined an array of 3 colors like this: color.white, color.red, and color.black. I have assigned this array to the blend.colors, which is basically an array of colors, and I have set the positions equal to a new array of floats, 0.51, and then I have used this blend to update the linear gradient brush that I have made, that interpolation colors. So by doing this code, I have specified that I want my brush to fill this ellipse in the way that it follows a forward diagonal shape, as you see. On the very beginning, in the top left, what I want is the first blend color, which is the white, position 0. Then at the middle at 0.5, which means the middle, I want the red color. And at the very end, which is the bottom right corner of this image, I want color the black. And then basically this one linearly changes the colors based on this forward diagonal pattern. Another type of brush, I would say the most complex type of brush, is path gradient brush, which allows you to create a brush with a custom made path. In this case, I have created this path. As you see, I have basically a path of 5 points. The first one is set to 0, 0, which is the top left corner of my form. The second one is width 0, where width is basically the width of the client rectangle, as you see here. That's the second point. So I will call this index 0. This one is index 1. And then this corner is going to be this third point, which has a width or x value equal to width and y value equal to height over 2. Then I have this bottom point where the x is width over 2, but the y is height, and that's my fourth point. And then the last point in this pentagon would be 0 and height over 2. 0 is the x, or the horizontal distance from the left border of this form in terms of pixels, and the y, which is the distance from the top border, would be height over 2. And then these 5 points are stored in an array called pentapoints, and this array is going to be passed to g.fillPolygon method. What is g? G is the graphics object that we have for a form, and basically, you know, the array of 5 points that I showed you is going to be passed as a second parameter of this. The first parameter, which is the path gradient brush B, is generated using the constructor of path gradient brush, which gets the same array of points, right? You can set the color of each vertex of this pentagon by assigning this array of 5 different colors to the surround colors array of path gradient brush. So you say B, after casting to path gradient brush, dot surround colors should be set equal to new colors. Red, that would be the color of the first point. Blue, second point. Green, third point. Yellow, fourth point, and purple, the last point. And then you have to let the path gradient brush to fill the whole shape, in this case a pentagon, with the colors that you want. Whenever it wants to blend them, it uses linear gradient operation. You can use path gradient brushes to fill an area by tiling it using a small patterns. Here is a simple example. I have created a graphics path, which is an object of graphics path, which is a predefined class. And I have added an ellipse with location 0, 0 and dimensions 25 pixel by 20 pixels, the width and height. And then this is my single tile, and I have said let's use a path gradient brush. I passed this object of graphics path to it as its only constructor, as its only parameter of its constructor. And then I have said let's set the wrap mode of this brush to tile. I can set it to the tiles that flip on X direction, Y direction, or both X and Y direction, similar to the texture brushes. And then I have set the surround colors to the white only, and then the center color to black. As you see, there's an ellipse in each tile. The center is black, and the surround colors are white. And then I have used the same brush to basically call the fill rectangle on the graphics object G, and the area will be the whole form, which is this client rectangle. And as you see, the outcome looks like this. While brushes allows us to fill different shapes, pens allow us to frame them and draw new shapes. All you need to do to use a pen in Windows Form applications is to instantiate from the pen class this way. You can pass, let's say, a color as its first parameter, and the width as its second parameter of its constructor, and this way you can create a pen. Now this pen has a width of 12 pixels, and the color is black. You can change the color or the width if you want a different color, or if you want to have a thinner or thicker line. I should say thinner or thicker pen. And then you can set the end cap to whatever shape you want. The default is flat cap, but there are different line caps that you can pick by going through this enumerator. Then you can use the pen that you created to draw a line, for example, using the graphics object G, and then that draw line method gets a pen first, then it gets the initial location. Let's say this is the initial location. Then it gets the final location, which seems to be here, and it's going to draw a black line from here to here, right? Now you may say, what happened to this image? You only have this black line from beginning to the middle. Why do you extend it all the way to this location? The answer is later I have created another pen in this code snippet, and I have made a different color. This is a white color and a different width. Let's say 20 pixels, and I have filled, or I have drawn another line with the new pen, with the white pen, from this middle point all the way to the bottom right corner of this form. This white one has masked the black one because it's wider, so you don't see the black one behind it. So we actually have two colors that are overlapping partially. And yeah, that's pretty much it. If you want the black one to overlap the white one, you need to draw the black one after the white one. You can customize the pen by changing its line cap to one of the values that you see here in this top left shape. You have arrow anchor, custom, diamond anchor, flat, no anchor, round anchor, square anchor, triangle. And also you can change this dash style to either custom style or dash dot dot dash solid or other styles. In order to customize the dash style, what you can do is to define a pattern by creating an array of floats and pass a bunch of floats here, and then basically the pen that is generated with this dash pattern will look like this. Now you might say, how does this pattern can be specified by this array? I can tell you how it's possible. First, I use one, or I store one in this float array. That means I have one unit of width, followed by the other one, which is going to be the space, followed by the 2, which shows the width of the next dash, followed by 1, which shows the space between the current dash and the next dash. Then I have 3f, the width of the next dash. Then I have 1f, which is the width of the gap between the current dash and the next dash. Then I have 4f, that's the width of this dash, and then 1f, which is the space between the current dash and the next dash. After this, we're going to repeat the same pattern in a periodic fashion. So as you see, this pattern that I specified with green color has been repeated once here, once here, once here, and partially here. Why partially? Because we don't have enough space to draw the rest. So that's how you can create your dash styles by using an array of floats.